Welcome back my dear friends. A very good morning, good afternoon, good evening to all of you wherever you are in this part of the globe, and welcome to this DADM3, which is Data Analysis and Decision Making 3 course under NPTEL MOOC series. And you know this course total duration is 30 hours contact hours, which is 60 lectures and spread over 12 weeks. Each week we have 5 lectures. After the 5 lectures we have an assignment, and in totality you will have 12 assignments, and as you can see from the slide we are in the 9th week. That means you have already completed 8 assignments and you will go into the 9th assignment after the end of this week. So, if you remember, we were in the last example we discussed the production of the cars, but very innovatively we converted and brought into the picture a set of 0-1 variables in order to basically divide the total range of the x1, x2 and x3, which is the production number of cars to be produced for type 1 of variety 1, which is compact, similarly for the type 2 and the type 3. They were basically discrete regions. Discrete is not, I am talking about the discrete numbers, discrete regions in the sense 1000 and above for all the 3 cars, and generally the other cars they can be 0 or 1000 and above, nothing in between. For based on that, when we solved, we found out that the total profit was 3000 into 2000 depending on the number of cars which is being manufactured for only one type. But the moment we remove the restriction that the number of cars has to be 1000 and above, then we see the total scenario changes. So, obviously, it will depend on how the problem formulations and the constraints are. Now, we will basically as happened in the 41st lecture, we started discussing the Indian Auto example, but I switched over and basically discussed the whole problem in the 42nd lecture. Similarly, in the end of the 42nd lecture, I was trying to basically start off the discussion of a new example. Again, I will start in the 43rd lecture. So, there would be few slide repetition, but that will if I did not do that, then that will break the continuity. That is why I am doing that. So, please bear with me. So, overall problem I am again repeating, you have heard in the 42nd lecture, but so that is just a repetition, and it will make things much more clearer to you. Jagdish Investment Company is a company which is considering 4 investments. The net present value from investment 1, I will not consider the 1000 value. So, it is basically I may or may not, depending on how the problem formulations are being stated by me as I discuss the problem. So, net present value from investment 1 is 16,000, investment 2 net present value is 22,000. Net present value means the value as of now, today. Similarly, for investment 3 it is 12,000, investment 4 is 8,000. Each investment, which is investment 1, 2, 3, 4, requires a certain cash outflows at the present time. So, you basically have to give some cash, or cash would be going out of your pocket or out of the pocket of Jagdish Investment Company Limited. So, they are as follows. For investment 1 is as of now it is 5,000, investment 2 is 7,000, investment 3 is 4,000 and investment 4 is 3,000. Currently, total amount of money which is available in your pocket or available in Jagdish company is 14,000, which means that 14,000 has to be apportioned proportionally depending on what the investments are. So, it is like this: if you invest investment 2 7,000 and then you invest investment 4 which is 3,000, and then you can invest investment 3 which is 4,000. So, total 7 plus 3 plus 4 is 14,000. So, you would not have any amount of money left for investment 1. So, there can be different combinations. So, let me continue reading it. Currently, in 14,000 is in Indian rupees is available for investment. Formulate an integer programming problem whose solution will tell Jagdish Investment Company Limited how to maximize the net present obtained from the investment numbers 1, 2, 3, 4. So, as in linear programming formulations, we begin by defining a variable for each of the decisions. So, what are the variables? It is x1, x2, x3 and x4. So, what are x1, x2, x3, x4? Technically, they should have been considered as y1, y2, y3, y4, because we consider y as 0, 1, 0, 1 variables in the general formulation of the problem, but we will consider x1, x2, x3, x4. as the decisions that you want to invest in investment 1, x2 corresponding to the second investment, x3 corresponding to the third investment, x4 corresponding to the fourth investment. So, this leads us to define a 0 1 variable where x1 is 1 if investment is 1 is made, as I said. Similarly, x2 is 1 when investment 2 is made. Similarly, x3 is 1 if investment 3 is made, and x4 is 1 if investment 4 is made. So, for example, I will repeat it, x1 x2 is 1 in investment 2 is made, x2 is 0 if investment 2 is not made. So, if I consider the total net present value coming out from investment 1, 2, 3, 4, which were respective values of 16,000, 22,000, 12,000 and 8,000, the total net present value obtained by Jagdish company, investment company would be 16 x1. So, x1 can be 0 and 1. If x1 is 1, so obviously net present value is there. If x1 is 0, so there is no net present value from investment 1, plus 22 x2 plus 12 x3 plus 8 x4. Now, to see, so if xj is 1, that can be 1, 2, 3 for anything, then the above equation includes the net present value for the jth one. If xj is 0, the above equation would definitely not consider the investment from the first, second or third or fourth, as j is for the investment. So, this means that whatever combination of investment is undertaken, the above equation gives the net present value of that combination of the project or the conglomeration of the projects. For example, if Jagdish Investment and Company invest in investment 1 and 2, the net present value will be coming because x1 is 1, 1 and 4 sorry, x1 is 1 and x4 is 1, while x2 and x3 are 0. So, in that case it will be 16,000 plus 8,000. So, the total value is 24,000 will be obtained. This combination of investment which we just discussed would mean that x1 is equal to x4 is equal to 1, and while the corresponding values of x2 and x3 are 0. So, the above equation would yield the combination which I just repeated, 16 into 1 because x1 is 1, plus 22 into 0 because x2 is 0, plus 12 into 0 because x3 is 0, plus 8 into 1 because x4 is 1. So, the total value is 24,000. This reasoning implies that Jagdish's investment objective function is already, as I have stated, 16 x1 plus 22 x2 plus 12 x3 plus 8 x4. Now, the constraints, so which are very simple constraints. So, Jagdish Investment Company faces the constraint that at most 14,000 can be invested. So, at any point of time it cannot take out 14,000 from its more than that from its pocket. By the same reasoning, we used to develop the above equation. As said, we can show the total amount invested in 1000 hours in rupees would be, this equation would be true, which I will now go back to the initial problem and state that why this equation is true. So, here I will use two different colors. For the first one is the net present value. So, I will use the yellow color. Now, is the total amount of investments. I will use the green, light green color. Investment 1 5,000, investment 2 7,000, investment 3 4,000, investment 4 3,000. So, it will be, if you invest, so 5,000 from 1, 7,000 from 2, 4,000 from 3 and 3,000 from 4. You have to take out from your pocket corresponding to the fact the total amount cannot exceed 14,000. So, let us see. So, the values are, I am omitting the 1000, it is 5, 7, 4, 3. So, here it is 5 into x1 if it is invested in first, 7 into x2 if it is investment in second, 4 into x3 if it is investment in third and 3 into x4 if it is invested in fourth. So, x1, x2, x3, x4 can be 0 or 1 depending on the problem, not on the problem like the decision which is being taken. Again x1 is 0 and if x2, x3, x4 is 1, then means that Jagdish Investment Company has made investments in second, third, fourth decisions and not in the first. So, in that case Jagdish's total investment would mean that it should invest 7,000 in the second, 4,000 in the third and 3,000 in the fourth. So, the total amount of investment would be, because it is not investing in the first one. So, it will be 5 into 0 plus 7 into 1. So, this 0 and 1 are the corresponding values of the 0 and 1 integer values you are getting. 7 into 1 plus 4 into 1 which is for the third one, and the last one is 3 into 1 which is for the fourth one. So, the total value of investment which is coming out from your pocket is 14,000, and what is the total value available? It is 14,000 in this example also. So, if I formulate, the constraint becomes 5 x 1 plus 7 x 2 plus 4 x 3 plus 3 x 4 is less than equal to 14. So, you cannot exceed, but you can basically spend less. Combining these equations, what are these equations? One was corresponding to the net present value for each and every investment which was there, which was corresponding to 16 x 1 plus 22 x 2 plus 12 x 3 plus 8 x 4 plus 5 x 1, and for 8 x 4 was basically the objective function. So, I will use the color yellow as I have been using. So, this also comes here and the constraints are corresponding to the green color which is less than or equal to 14. This is true. So, this yields this 0 1 programming, and you have 4 decision variables 0 and 1 based on which you can solve. Now, I will come to the concept of quadratic programming, and based on the general formulation some ideas, I will just build up the ideas and then go into the concept building of that. Now, where quadratic programming would be important, and there is a background for that. So, consider that you are trying to solve a problem. So, whenever you solve a problem, you have to either maximize or minimize. When you are trying to maximize and minimize, forget about optimization. Generally what we do, we basically try to use the concept of dy dx or differentiation, try to find out that the value is 0, and then at the second derivative try to find out whether it is positive or negative. Based on that, we can pass on the judgments that whether it is maximization or minimization. Now, if you also remember that if the second derivative is also 0, it is basically the point of inflection where the rate of change of that function is changing from positive to negative or negative to positive. So, if you remember seeing the normal distribution curve. So, the normal distribution curve and I am talking about the standard normal distribution curve, the mean value is 0 and the standard deviation is 1. So, the point where on to the right of the value of 0, if you are going on to the right hand side or you are going to the left hand side, one standard deviation movement from the mean value or the median or the mode also, because for the normal distribution mean, median, mode are the same values. So, one standard deviation moving to the right and one standard deviation movement to the left would basically bring those points in the curve where the rate of change of the function changes from positive to negative or negative to positive depending on which side of the equation you are looking. That means, of which side of the curve you are looking, on the left hand side or the right hand side. Now, in quadratic programming we will try to utilize, I am not talking about the point of inflection which will be utilized in quadratic programming, but we will try to utilize the concept that the rate of change of the function, whether if dy dx is positive or negative, and if it is 0, then in the second case we will try to utilize the second derivative. So, but the issue is that in many of the cases we have basically the multivariate cases. Multivariate cases means there are more than or multivariate decision variables, that means there are more than one number of decision variables, it can be n in number, that means x 1, x 2, x 3 till x n depending on how the problem formulation has been done. Now, a quadratic optimization problem is a optimization problem where there would be two parts. One would be a quadratic part, which is this, and one is the linear part, which is this one. So, you have the quadratic part as half. So, this t x to the power x t is the transpose, remember that. So, that would be either be a vector, a column vector or the row vector, depending on that how the formulation has been done. But remember one thing, that if x, q and x transpose are all of them are like this. So, if x is basically a vector, column or row, that is immaterial now. If and x transpose obviously as x is a row or a column vector, and q is a matrix. So, in that case the multiplication which you are going to do should basically have the similarity or the compatibility or the concept of rows and columns would be similar, which means if x is the value, and obviously the z value which you are going to get at the end would be one value. So, you want to basically maximize one scalar quantity. So, in the case if you want to formulate, so x transpose would be, say for example, of size m cross m, 1 cross m, then the size of q would be m cross n, but here even though I am writing n, it need not be n, it has to be of the same size, because or else the matrix multiplication would not be compatible. So, let me write in m, and the third case would basically be the value of x. So, if x transpose is m cross 1, so it will be 1 cross m, it will be m cross 1. So, when I multiply the total values, it will be 1 cross m into m cross m is 1 cross m, and when I am multiplying 1 cross m into m cross 1, it will be 1 cross 1, which is a value. Similarly, when I go to c transpose into x, I already know the value of x, value means the size of x as m cross 1. So, the value of c technically would be 1 cross m is a transpose. So, 1 cross m into m cross 1 would be another one value. So, you have basically a quadratic part, because this is a square, and one is the linear part. So, what can be, I will give you an example, I will come to the general solution methodology later on. Consider you have, I had discussed a very small problem in DADM 2, which I will go into details in DADM 3. So, consider you have one portfolio, and the portfolio consists of n number of stocks in very simple sense, and it is given that the price or the returns of each and every stock is given on an average, and I want to find out the decision variables like this. I have 100 rupees, or I have, say for example, whatever amount it is there, I want to invest in these stocks. Consider I am formulating the problem as the proportion of investment. So, the proportions of investments are W1 to Wn, and this 1 to n are all suffixes, which I have already mentioned when I was starting the last lecture. So, all are suffixes. So, what I want to find out is that the average return of the combination of the investment which I am going to make in the proportions of W1 to Wn in the stocks 1 to n, where the returns are given by R1 to Rn, that should be maximized. So, that would be corresponding to the yellow part which is there, the highlighted one, which is the linear part. Now, what is by the way, do not concentrate on the minimization maximization, I am only talking about the problem formulation. What would be the quadratic part? Because we know that whenever we want to basically do such combinations in portfolio management, we need to basically minimize the risk. So, what is risk? Technically risk is considered as the variance. So, if I have basically n number of stocks, the total variance would basically be considered taken into consideration the variances of each and every stock plus the covariances which exist between the ith and the j stock. When I am talking about the covariances, generally I would have the covariances as n cross n matrix, because n is the number of stocks. So, where the principal diagonal is the variances of the first stock. So, the 1 cross 1 element is the variance of the first stock, 2 cross 2 means the second element, 2 comma 2 is the variance of the second element, so on and so forth till the n comma n, which is the variance of the nth element. And the off the diagonal element are basically the covariance of the first ith to the jth, and the mirror image of that would be the covariance of the jth to the ith. So, if I consider this, then it technically is a quadratic function, because generally the variance concept is what? It is basically the expected value of x minus mu whole square. So, that means I am trying to find out the expected value of the differences of the random variables from its mean value. Now, the idea which I told to not to basically consider is in depth and ignore is because the minimization concept of the idea which is written. So, generally whenever you are investing in stocks, your main idea would be to maximize the return, which is the yellow part highlighted. I will write it in this lecture as I proceed. I will create a new blank PPT and write it. And the second point is basically the green part which is highlighted is basically the quadratic part which you have. So, I will come to the other 3 points later on, but let me first write down the problem in its practicality such that you can understand. So, I will just discard it. So, it will be removed. It is like this. So, you have I is equal to 1 capital N or small n, whatever it is. So, I will use the black color, but I will to write, then I will highlight it in order to bring the concept of that yellow color and the green color which was being used. Let me use the. So, these are I's, investments are WI's. So, which means they are W1, which will also imply summation of Wi. These are the proportions, remember, is 1, because W1 till Wn should be 1. Returns for each stocks are given by R1. Bar is basically the sample average. You are aware of what the sample is, but I will use the bar or without the bar depending on that. So, this is the best estimate of mu 1, which is the return from the population return from the first one on the first stock. So, this is an R n bar, this best estimate is mu n. So, when I formulate that C transport x, so x are basically the W1 to Wn. So, I will highlight using the yellow color. So, these are the C's. And I need to find out, no, I will interchange it, is because if I consider x as the decision variable. So, I will consider W1 to Wn as the decision variable. So, these are the x's, and if I consider the c's which are the returns, I will consider these are the returns. So, if I combine, it will be basically W1 R1 bar plus. So, I am basically writing all of this would be so this is the CTX. CT means C transpose X. While if I come to, so this is akin to somewhere the colors are not very bright. So, this is CTX which I have utilized. Now, when I come to the quadratic part, so now I have the variances. I am not only talking about the variances, not the covariances. So, their best estimate would be S1 squares till Sn squares. So, this is n. So, this is, and the covariance variance matrix is also there. So, it will be like this. So, I am writing the population values. So, I can replace them with the estimates from the sample, but in order to make life simple for us, let us write it. So, sigma 1 1, this is the 1 comma 1 element, sigma n n, which is n comma n element, and the of the diagonal element as given. So, this is basically n 1, this is 1 n. So, they are symmetric. So, this is basically the variance covariance matrix which you have. So, what you want to do? You want to basically minimize this. So, what the formulation is? I'll create another one. Keep. So, your formulation is, because weights would be coming. So, as it is a variance, it will be squared. So, what I actually would have for the variance for the whole portfolio would be Wi Wj sigma ij double summation for I is equal to j is equal to 1 till n. If I is equal to 1 and j is equal to 1, I is equal to 2, j is equal to 2, you will basically have the whole principal diagonal. So, those values I am going to write for our understanding. W1 square, because they are squares, the ij are equal, is sigma 1 1 till the last in that principal diagonal will be Wn square sigma n n, and the of the diagonal elements are mirror images, they are same. So, obviously, a sign 2 will come, and the values, if I consider the first row W1 W2 sigma 1 sigma 2 into row 1 2, or else this is all is equal to W1 W2 row 1 2. So, basically this is this. So, if you remember, this value of 2 you have seen was here. So, it is divided by half in order to basically eliminate that. So, you will basically utilize this in a sense that you will minimize this whole thing, you will minimize this. So, half W1 W2 in sigma 1 ij. Now, you are thinking that how does it make sense with x transpose into q into x? It is very simple. This is what, if I basically think as a term. So, I would have basically, I am just drawing the vectors. So, this is 1 cross n, this is n cross n, this is n cross 1. What are these? W1 till Wn, sigma 1, sigma 1 n, sigma n 1, sigma n n, W1, Wn. So, if you see the whole value here, this whole thing is exactly this, or equal to that half sign is coming half into x transpose q into x. I will continue discussing such problems later on, but I thought I will give you a practical example and come into the general properties based on which we will proceed. Have a nice day and thank you very much.